Okay, I guess we'll get started. Thanks for the really good attendance here. So basically, it's about creating your own forecasting models and a little bit about the Excel 2016 tool. So again, my name is Wayne Winston. Taught at Kelley School of Business at Indiana University for 38, 39 years. Going to beat North Carolina Friday night. And we have a Tar Heel? Okay, that's okay. Actually, we probably won't beat them. I have to talk a good game. Okay, but then we had a good retirement plan, so I've been teaching at the University of Houston. We have any University of Houston. Probably the best football coach in the country at the University of Houston. I'm a big sports fan. And after the talk, if in the hall you want to talk to me about anything, today I have to leave for a meeting at 4, but I'd be around plenty tomorrow. Let me just put my email up here. And I do have a talk, I believe, at 2 tomorrow, and I'm totally free after that. But I think my business cards all got taken. But I used that email, let's see. And then my phone number, if you have any question. I guess my specialty is Excel, analytics, the more mathematical part of Excel is sort of, I guess, what I think I'm sort of best at. And so so how many people in the room have to do some forecasting in their job? I would think you wouldn't be here. And forecasting is really hard. I think you know that. And again, I told my previous talk, it's a pleasure I love teaching college, but it's really a pleasure to talk once in a while with people who have real jobs. Okay, and have to actually do this in the business world or the nonprofit world or whatever. So basically, how many people use something they learned in school to do forecasting at work? I'll bet very few hands go up. Okay, regression, is that what you use, or in the back? Okay, but lots of you have to forecast, and you didn't learn much in school that would help you forecast. And I think that's really an indictment of the way we teach a lot of business and stats classes. So regression is important. I'm not going to talk too much about, I'm sort of going to do regression without doing regression. So I should make this, if that probably doesn't make sense at this point. Let's see if I can get this bigger. Okay, so can we see that in the back? Okay, you can't? Okay. So it's okay, I'm trying to just click on that and make it, there we go. Oh, I could use the mouse to scroll it. Okay. So, when I teach, I totally teach by, now, gosh, I have to make this one bigger. Okay. So there, I should have done this beforehand. Can't make it too big or you can't see it. So I'm just going to go through 4 or 5, as many examples as I have time for. I'll stop by 2:40, have to stop by probably 2:45, of how you use the Excel solver to build your own forecasting models. How many people have used Solver? Okay, but if you haven't used Solver, don't worry about it. But Solver is usually used like to maximize profit, what products to make, or do an optimization of a portfolio, and that's absolutely fine. Okay, but it's sort of not, I think what I'm going to focus on is something that can really enhance the way you do forecasting, because you can build your own models. You don't have to depend on anybody else. If you understand what's going on in your business, you can probably build a good model on your own. Okay, and I think it's hard to automate forecasting. There are tools that try and do that, but I think it's rough. Okay, so here's an example. This is unfortunately 20 years ago. The Indiana University Credit Union, this is daily customer account, I think in 1992. This is before direct deposit. I was the last person in the university to do direct deposit. They said, Wayne, you won't get paid unless you do direct deposit. I said, I want a check to prove it. Okay, but finally I succumbed, like all of us, to direct deposit. Okay, so what we're trying to do is predict. We know the month of the year. January is month 1. Day of the week, 1 is Monday, 5 is Friday. Day of the month we also know. And the credit union, we only have Monday through Friday data here. But basically, this is how many people showed up at that, call it a bank, okay, every day. And the thing that makes forecasting hard, I think, for most of you, and I'd love to talk to you about your forecasting problems, is special factors. There's things going on, like Easter, if you're in the fashion business. Easter's important. Easter moves. Easter doesn't know it's supposed to be the same day. It's Sunday. Okay, right? Okay, and basically that's pretty early for Easter. Passover is April 20-something. Okay, so these things move around, and they affect a lot of people's business. The timing between Christmas and Thanksgiving affects the business for a lot of people. And so it's really hard to account for this in some automated package. Okay, so basically what I like to, so I think about what might affect the number of people coming to the bank before direct deposit, the day of the week. Banks are usually busy on Monday and Friday. I mean, the recent, I wish I could probably get more recent data. I should look into it. Okay, and then basically the month of the year. Is there any seasonality? How many of you think you're in a business with seasonality? I would think most of you. And that's where this stuff comes in really handy. Trying to understand the seasonality of your business is really critical. And I can empower you, I think, to do that yourself with the Excel solver. Okay, and I'm using 2016 here, but it doesn't matter. You could have 2010. I mean, anything back that far will do what I'm talking about today. Okay, so the IU Credit Union's a bit different because it's University Credit Union. So the faculty gets paid basically the first day of the month, and then the bank would be busy because we want to put our paycheck in the days of the paycheck. The staff got paid every other Friday, and so it would be busy on the Fridays, every other Friday. But then the question is, Friday's busy at the bank, but is it busy because it's a staff payday, or is it busy because it's a Friday? And how do you separate out, how to try and decompose this stuff is not an easy issue. Okay, so I coded with if statements like, basically I put the data in. Also, holidays. The bank is busy before a holiday, the bank is busy after a holiday, except for one holiday, Thanksgiving. In a university town, the day after Thanksgiving, nobody's there, okay? And so basically, you can't treat all the holidays the same. And so you just have to figure this stuff out. So what I do is solver basically has three parts to a solver model. A target cell, an objective you want to maximize or minimize, okay? That may max profit, minimize cost, minimize risk. But here we're going to minimize the error in our forecast. All these models, you want to minimize some of squared errors or average absolute error. There are many but basically you want to make sure your predictions match your actuals. Okay, so we square errors Y, so positive and negative errors don't cancel out. And actually with Solver, you can set up any criteria for your forecast accurate. You can minimize the worst error. You can do whatever you want. It doesn't matter. Okay, so the first part of Solver is objective. That's going to be to make forecasts as accurate as possible. The second part of Solver is changing cells. What can we change? What parameters define our model? So in our examples, the parameters that define our model, like I hope to do NFL, I picked Carolina to win the Super Bowl. Okay, I had him to win the NFC, and I was close, but Peyton Manning played a terrible game. He goes out a winner, although it's off the court issues, but we won't comment. Okay, those commercials are bad. Okay, but basically, so how would you, if you worked for a bank, how would you forecast things? Okay, what's a simple model you could start with? There's a base level of customers that come in every day. And then the day of the week, if you should add or subtract, it's a busy day or not. Then the month of the year, add or subtract depending on how, add or subtract based on is it a busy month or not. And then you have the special factors. Like if it's a staff payday, you're probably going to have more people show up. If it's a faculty payday, more people will show up. If it's before a holiday, more people will show up. If it's after a holiday, more people will show up. And so basically, but you don't know how many more will show up if it's a staff payday. That's the whole point. And in essence, we're doing a regression here, but we're not using, it's so transparent, I think, what we're doing here. Okay, so the forecast, so what you do is you set up changing cells in Solver. So the credit union, I won't be able to do all the details of this example, but you have a day of the week effect. So that 100 would mean basically 100 more people came on a Monday, 200 more people came on a Friday, and then you have a month of the year effect. We don't know what those are. We can start with any, and then there's a base level. Okay. And then here's the special factors. Put those in a different color. Okay, like that's how many more, so your forecast model says start with the base level, bump it up based on the day of the week, bump it up based on the month of the year, or bump it down, and then add the special factors. It's a basic additive model. And again, I had no idea when I start what these numbers should be. It doesn't really matter. But what the principle of all these models is, I will create a column that's the forecast based on the changing cells. And then I will do the error, and I'll square the error and minimize the sum of the squared errors. And this is Solver models can be linear. That means you have changing cell times constant in all parts of your model. No forecast model is linear because you're squaring the errors. But you can have a linear forecast model when you add up stuff that depends on your changing cells. You can also have multiplicative, and that's trickier, and I'll get to that next. And you can try both, like I could have tried multiplicative, which I'll show you later for this model. I don't think it would have done any better, but it's easy to try different models. So the key to everything we're doing here is this formula, which looks horrible. Okay, but basically it's very simple. I take the base level, I do a VLOOKUP based on the day of the week, the month of the year. If it's month one, I add the month one effect. And then I do a lookup based on the day of the week. If it's day one, I do the Monday factor. And then I add terms. If there's a 1 in the column for staff payday, faculty payday, before holiday or after holiday, I add that effect. So that's just basic Excel. In other words, the question I'll always get on this model is, how do you know what these numbers are? Okay, well, I'll start with anything in there. But in other words, you don't have to know what you just build the model with these unknown parameters, and then Solver will figure them out. How will Solver figure them out? Like in football, if Solver said that the Cleveland Browns were a good team, okay, then basically you would know you had a mistake. Okay, did you hear this story on Siri? I can mention Siri even though this is Microsoft. They put in for Cleveland sorrow, and it gave a picture of the Cleveland Browns stadium. Okay, but basically, like, I can change these numbers. I can make them all pretty worthless numbers. Like, I can say there's nothing going on here. Just put all zeros there. I mean, I don't care. In other words, I'm starting with numbers there that are totally worthless. Okay, I'll change the base level to something, let's say 400. I just made those up on the spot. Okay, now how do I set up a solver model? Well, question.
So is your base just the average?
It would basically, well, it might be it depends how I normalize, like the sum of the month effects being 0 and the day. See, it's not quite the average because the special factors bump things up. See, in other words, the special factors might have an average of 50 a day, so my constant might be 50 below the base average. It's not quite that simple. You see, because the special factors could bump stuff. If I took a straight average, that includes days with special factors.
So would you take an average of all the days that don't have...
Solver will figure it. I don't have to think. Yeah, Solver will figure out what the constant is. But I'm quite sure it's not. I know it's not the average. Okay, but you don't have to. You got to think about the model and I always tell my students, and when I teach Solver a lot. And basically, I always tell them, don't try and guess the answer. Let Solver figure it out. And Solver is a really powerful tool. But let me just ask, has anybody used how many people have used GRG multi-start? Does that ring a bell? Okay, you'll learn something I think very useful. How many people have used evolutionary solver? See, okay, these are key parts of Solver that most people don't know about. And a lot of you have used Solver, but the GRG multi-start and evolutionary, and I don't have time to talk in great detail about evolutionary, but GRG multi-start, which I'll explain, is the key to what we're going to be doing here. I don't need in this example. But see, so these forecasts look like worthless forecasts. But what can I do to find out what those numbers should be? I create for each row the squared error. I take the actual customer count minus the prediction from that lookup equation, and I square that and add them up. That's my target cell. Minimize the sum of the squared errors. And there's an R squared function in Excel that will tell you the R squared between your actuals and predictions. So even if you do nothing that I teach you today except this, if you have forecasts at your company and you have your actuals, and every company should keep actuals and forecasts. It's really quite important. A lot of companies don't. But if I do an R squared between actuals and forecasts, you should always look at that. That should be close to 1. It's a percentage of variation that your predictions explain in of your actuals. It's never going to be 100%, especially in sports. But I want to minimize the sum of squared errors. So now I bring up Solver. Okay, and don't have time to put this in, but I'm minimizing the sum of the squared errors. The changing cells are those parameters of the forecast. You can hardly see that. But those are the day of the week and the special factors. Those are the month of the year and the constant term. And then I put in a constraint that basically, okay, what's R4 and R4 and R5? I forgot about those. R4 is the average of the day of the week effects. I made that 0. R5 is the average of the month effects. Now, why do I want to make that 0? So a plus means it's a busier day of the week than average, and a minus means it's a less busy day of the week than average. Okay, because, I don't have to do that, but that affects the question that was asked. What the constant would be. Okay, so now going back to that solver window, the only constraints I have here, and usually you check your variable, changing cells are non-negative. That would be stupid here, because if there's a busier day of the week like Monday, there must be a less busy day like Wednesday, right? And so I want to make sure I uncheck that box. Now what are the three options in Solver? The three options in Solver are linear, which unless you're in supply chain is pretty rare. I mean, I'm not here to talk about linear models. Nonlinear means your target cell or your constraints have like variables squared, variables to a power or something like that. Okay, and the only way our forecast formula was linear. I never raised things to a power, but the squared errors makes it nonlinear. But this is a model that Solver does great on. You don't have to worry about that multi-start or anything else. If you have a linear forecast model, it's like running a regression. This is sort of equivalent to a regression. But see, you can explain this to people. You can see exactly what we set up. So evolutionary is what you use if you run a Solver model where you want to use if statements involving your changing cells, you should be using evolutionary. I mean, I don't have much, I'd be glad to talk in the hall to anybody about evolutionary. Just don't have much time to talk about that today. But basically, if we go to GRG nonlinear, okay, and we click solve, even though the numbers I put in were garbage, by minimizing squared errors, what's it going to do? It'll say Monday and Friday have plus coefficients and Wednesday has a minus. It'll say a staff payday has a positive coefficient because otherwise it won't forecast well. It's like making the Browns a good team. We wish. Okay, if you're from Cleveland. Okay. Okay, so it says Solver found a solution. Okay, and basically I've explained 77% of the variation in the customer count by our model. And you can see a staff payday bumped things up by 400, faculty payday by 400, before a holiday 205, after a holiday 250. And now I did much more with this model, and I'll just briefly outline it because I want to go on to the other models. Although what I've done so far is very important. When you have a forecast model, you should always look for outliers. Outliers are when your forecasts are off by more than, if you take your forecast error, okay, and you take the standard deviation of it, anything in absolute value more than double the standard deviation of the errors is an outlier. That's the easiest definition. The standard deviation of my forecast errors was 163. So any day that was off by more than double, that's an outlier. Why are outliers so important? Because if you have a pattern in your outliers, it should be in the model. And outliers in forecasting will kill you. I mean, they'll really hurt you in business. Okay, so like I can see January, this is January 3rd, way more people came in. And what you'll see in this model is if I look at all the outliers, they're always basically early in the month. So like my model did not, you recall I had the day of the month, but I didn't use it in the model. This is before direct deposit. What happens early in the month? Social Security and welfare checks. And so people go to the bank to put them in. And now that doesn't matter. But I mean, but then it was a huge effect. So what should I do in the next spreadsheet? And I don't have much time to go through that. I should add changing cells for like, is it one of the first 3 days of the month? And add that to the forecast and minimize the squared errors. And I mean, I'll show you the result. Okay, the first 3 days, and then I look at the outliers again to see what I'm missing. Okay, but if you look here, see I added changing cells for the first 3 days of the month right there. And you can see there are humongous effects. The first day of the month added basically 500 people when we're averaging about 1,000 a day. The second day of the month, 367. And then my R squared really goes up, and then I could check the outliers, and there were things I did wrong on holidays. And another thing you should check in forecasting besides outliers, you should look at sign changes. If you have like 6 or 7 days in a row that are plus errors or minus errors, there may be something going on you should add to the model. But see, with my approach, it's very easy to add things to the model. Change the forecasting equation, add changing cells, and run the solver. I mean, and it's very transparent what you're doing. And the final model, after I went through all the special factors, and I probably could have done a little better, like the bank. The week before Christmas, it's busy. The week between Christmas and New Year's, nobody comes to the because everybody's out of town, and they have no money left. Okay, my R squared went to 92%, and my standard deviation of 98 means 95% of the time you're accurate within 2 standard errors, which is 196 out of 1,000. That's plenty good to run a bank. I mean, why would you want to predict the customer account so you can schedule the tellers? I mean, a lot of you want to predict forecasts so you can schedule production. But I mean, I think you don't need me to tell you why in your business, or maybe they just need to forecast the revenue because that's how you guide, if you're a Fortune 500 company, that's how you guide Wall Street. Okay, so now let me go to another example, which is with the multi-start. Okay, so this one will involve marketing. I have a book called Marketing Analytics, which hasn't sold that well, but I got the best reviews of any book I wrote. Okay, but I mean, I'm had to work hard on that because I'm not the world's greatest expert in marketing, but the book I think turned out pretty well. But so let's see, Snickers, world's best-selling candy bar. Though my teeth are falling apart, I don't think I can eat Snickers anymore. Make sure you floss. That's the best advice I can give you. I flossed, it didn't help that much, but okay. But you're mostly younger than me, so you should floss. My wife flosses twice a day, and her teeth are doing great. Okay, so let's suppose, this is made up data, although I've done a model. Anybody here work for 3M? Okay, so I did a lot of models of trying to figure out what drives sales of the 3M home improvement products like Filtrate, Command, Painter's Tape, things like that. And those are really, like here's a good example from 3M. Okay, so for Painter's Tape, they advertise on HGTV. How many people watch HGTV? Wife watches it all the time. She got Love It or List It. Okay, I can always guess what they'll do. Okay, my wife's really impressed by that. Okay, but there's Love It or List It too, I know. Okay, I watch too much TV. Okay, so 3M Painter's Tape advertises in August. Okay, and so the big debate was, if you advertise in August, they say, well, it's working, we sell lots of Painter's Tape. Well, then somebody at the company said, well, people paint their house in August, you would sell it anyway. So, I mean, how do you know if the advertising is helping you? That may be an issue for a lot of your companies. So, I mean, so I've got a really simple, this model doesn't have advertising. Okay, but let's suppose you're selling candy bar, and if you're in the supermarket business, you have lots of things involved. You have this scanner data. Like, and so can you use the scanner data if you're Walmart, Target, or Fred Meyer supermarkets here, or Kroger's, or whatever, Whole Foods, or whatever supermarket. There's a Whole Foods right up the street, actually. Okay, you can't get up the street, though. If you go down 8th or fix oh my God. I got to go to Microsoft after this, and I don't like the freeway. I don't know what I'm going to do. Okay, so here's the data. Every week, what did we sell of our Snickers, okay? Now, this is where your knowledge of your business comes in, which I'm sure you're great at. What variables might affect the sales of the product? Now, I don't have seasonality in this particular example, but I think I will have seasonality when I teach you the Winner's Exponential Smoothing Method, which will be the next, probably last thing we'll have time for. Okay, but clearly the price I charge for Snickers will affect my sales. Clearly the competitor's price will affect my sales, or an average of the competitor's price. And advertising might be there. And the big thing at 3M was, if I put the product on display at Home Depot or Menards, what does that do? Because you got to pay to put it on display. So are you getting enough of a bump when you put the product on display? So I mean, these are real questions people have to answer. And we did this model, I mean, because the 3M manager, his question was, is it better for me to basically advertise, or should I just basically cut the price or something, put supplements in papers, or should I cut the price, things like that. These are hard decisions. So they had good data. I mean, so this is made up that I have every day, what I sold. I got my price, I've got the competitor's price, and a 1 means the product that was on display, and a 0 means it wasn't. Okay? And so then basically, what's a model, not an additive model? You could build it, with pricing, you never want an additive model. Like if you say sales equals 10 minus 5 times price. Why is that wrong? If price is high enough, demand is negative. I mean, that's got to be wrong. So there's a common model. It's not perfect, but this is what people, you can create any model for how your sales depend on price. Like for Post-it notes at 3M, they thought basically if you would sell it like once, $3.90, we're really stupid people. If they sell it to us for $3.99, we buy a lot more than if we charge $4. That really does work. They had the data from Target and Post-it notes. So I mean, but with what I'm teaching you, you can build flexible models. I mean, this is one model for demand, but for the Post-it example, you would have to say, if the price is in this range, here's what I think I'll sell. If the price is in that range, because it makes it's not going to be, that 1 cent makes a difference. And you could test that. I mean, it depends on your business. Okay, so the predicted sales, what's the equation we use? The whole thing boils down to, in every model, what equation do I use in the situation? And I can't go through every situation here, but you can create your own. I'm showing you some basic ones. Okay, but basically, once I create the equation, I have parameters that values of parameters, trial values for this equation. I'll explain it in a minute. And then I use solver to minimize squared errors. And this is one where I need the multi-start. Because you'll notice in the last forecasting equation, I just added stuff together. Here I'm multiplying stuff and raising it to powers. That's a much more complicated mathematical problem. That's where the multi-start comes in. Okay? So but let's go through this model. So this is a common marketing model. What do you think you'll sell in a week? Some base level, a constant. I don't think it's the average. But basically, you take your price raised to a power, which I called your own elasticity. So to anybody, if I say the elasticity, price elasticity is 2, what does that mean? Anybody know? I'm just curious. If elasticity is 2, what does that mean? It means if you raise the price 1%, you sell 2% less. It's a percentage term. So, but if you model stuff like price to a power, that power you get is the elasticity, okay? And then you multiply by the competitor's price to the competitive elasticity. In other words, this one will be negative. The higher your price, the less you'll sell. The higher the competitor's price, the more you'll sell, okay? And then you multiply by the display effect, the 1 or 0 to this power. So I could have done this with an if statement, but basically what this means is if there's a 1 in column F, this multiplies by display effect. So that might be a 1.1, which means sales are 10% higher with the display after adjusting for price. See, all the coefficients in these models are after adjusting for everything else. Okay, that's what regression does for you. And so if this is a 0, then anything to the 0 power is 1, and this just gets wiped out. So if this comes out to be like a 0.98, it would mean putting it on display cost me 2% of my sales. But if it's a 1.1, it means I sell 10% more in a week being on display, and I can figure out, should I be on display? I can figure out if I'm making enough money based on my profit margins. Okay, so now how do we make this thing go? So I just put that equation in, and a nice thing starting in Excel 2013, I hope you've used this function, formula text, because you can then see the formula. If you're trying to show people what people are doing. See, I use range names, I named my cells. So I took the changing cells are over here, okay? So I have the constant, these happen to be the right values, but I could start with anything in there, okay? So I take a base level times whatever the price was in column D raised to my elasticity power, which will be negative because I'll sell less. And then I take the competitor's price in column E raised to a power, and then I take whether it was on display or not, times the display effect. And then I minimize squared errors, just like I did before. So I've got the prediction, and it sounds like a broken record. I take the actual minus predicted squared. I throw this into solver. Now, the problem with it, okay, when you have a linear forecasting model, you don't need multi-start. But what is GRG? GRG means basically use calculus to find the answer. You remember, if you took calculus, when you want to maximize or minimize a function, you set the slope equal to 0. But if you remember calculus, most of us try and forget calculus. But basically, if you want to maximize, what problem can you have if you set the slope equal to 0 if there's multiple peaks and valleys? And when you have a function like this that's multiplicative, then you have multiple peaks and valleys. So what should you do? Try different starting points and find the best answer from each starting point. And that's what GRG multi-start does. I'll show you how to do it. So we set up the forecast equation, and this is called, I think, the ScanPro model in marketing. You can put special factors on it, put price. It's a very powerful model, okay? And so most people estimate it by taking logarithms, but most people hate logarithms. Okay, so if I would go to my solver window here, let's see there. Oh, I'm in that cell, I guess. Okay, so data. Okay, there we go. All right. So the thing with GRG, if you're going to use this multi-start, you need bounds on your changing cells, upper and lower bounds. It's got to, and they're pretty obvious to come up with. I want to minimize sum of squared errors. I want to change those 4 parameters. Elasticities are usually between 0 and 10. I've never seen that. I've never seen a display that would more than double your sales. That would have to be some display. Okay, I don't know what would be on that display. Okay. And then the competitor elasticity is probably between 0 and 2. It should be positive. And the constant, I never sold more than 5,000 there. So, I put in a bound of 5,000. Now, you might say, how do you come up with some of these bounds if they're not obvious? What you do is you set a bound and the solver bumps up against it, you raise the bound. You relax the bound because you may not be able to come up with the intuitive bounds. But okay, now how do I get the multi-start here? It might get the right answer if I didn't use the multi-start. Let me just start with different numbers here and see what happens. Okay, now multi-start, where do you find that? Okay, it's under options for GRG. And there, you see right there in the middle, there's your multi-start button. Okay, so if you have a complicated nonlinear model, as long as it doesn't have if statements, which are non-smooth, requires evolutionary. But if you have complicated functions like multiplying changing cells, squaring changing cells, sines and cosines, you should try multi-start. It's really good. What it does, it tries different starting combinations of the changing cells, finds the best answer from each one, and takes the best of the best. I mean, it's really quite good. Now, I'm going to uncheck multi-start. It might get the right answer here, but to be honest, I wouldn't, in most cases, be sure. Okay, but if I solve this, see, what happens when you hit the solve button? It just tries all the combinations possible that meet the constraints. Solver is really very magical. Really great if you know what to do with it. Okay, now that came up with the right answer, to be honest. Okay, but in general, I would need that multi-start button. I would feel much more comfortable knowing it's a multiplicative model. And if I run this with multi-start, I won't do any better, I'm quite sure. And then I'll interpret what this equation means. Okay, so it may take it a little longer here. I'm in the interest of time, I'll hit escape key to stop it. But it doesn't do any better. Solver, okay, but what do these coefficients mean? Okay, so I could forecast sales by taking 894 times my price raised to the minus 3.19 power. What does that mean? Raise my price 1%, I'll sell 3.2% less. What does this mean? Competitor raises his price 1%, I'll sell 0.4% more. What does this mean? After adjusting, see, the hard thing is, what's the effect of the display when you keep changing the price? But this model does that. I mean, you can parse out the effects of your decisions. After adjusting for price, I would sell 20% more. Okay? So that multi-start, running a little short of time. Let me show the football one. Okay, because I think the winner, well, let me show the winner's method because I like football more, but to be honest, the winner's method is more like what you need to know about in your job. Okay, unless your job's picking football games. Okay, so let's see. Winner's method. Okay, auto sales, use this one. So I'll show you the forecasting tool that's built into 2016. You may have seen the talk, at least I saw a talk at 10 a.m. on this. So a good site for macroeconomic data, it may not be the best one. It's called FRED, it's the St. Louis Federal Reserve. And so you can download a lot of things. They have a really nice app and add-in that lets you download a lot of macroeconomic data. If you, I mean, there may be a better site, but that's the best one I found. So I've got car sales, let's say, every month through end of 2015 here. Okay, and I guess this is in thousands of cars. I think it's thousands of cars. So basically what you want to do, this is definitely going to be seasonal. Okay, but so they put in Excel, Microsoft's put in Excel 2016 a new forecast function. Okay, if you just select your data and it's got dates in it, it will give you forecasts for the future. Now the problem is it's just hard, it uses the method I'm going to show you. How many people have used exponential smoothing for forecasting? Okay, just a couple. But that's, exponential smoothing is, what we just did was causal forecasting. We tried to figure out what caused what happened, right? But basically sometimes you just want to know what's going to come next and you're happy with that. I got to predict the next quarter's revenue. I mean, I'd like to know why it's going to go up or down, but I got to get a number. I mean, because that's just the way, I know Microsoft, that's a huge focus, predicting during the quarter what's the rest of the quarter going to be. And if I had more time, I'd talk about that. But see, if I select this here, I do Control-Shift, oops, sorry. Control-Shift right arrow, Control-Shift down arrow, which is helpful. And I should go through 2010 here. I think through here. So, because I want to show the forecast for the remaining, these are the forecasts it created. But if I go data, it should go forecast sheet. And see, there's your forecast. See, there's your actual data. Then it shows forecast. And I can create a forecast sheet with the forecast for the remaining months. See, if I do create, and I just cut, that's how easy it is to use that forecast tool. See, in other words, basically there's the actual data, and then it starts making forecasts. And it's supposed to pick up seasonality and stuff like that, but so there's my forecasts right there, and it gives confidence intervals like 95% sure. If I predict 317, it's between 200 and 433, et cetera. Okay, and it's got but I want to teach you exponential smoothing because you really should understand the concept that I think in the remaining 10 minutes or so I can do that. So, okay, so that's how we'll keep those forecasts in mind they're based mainly on exponential smoothing, but I want to show you the sort of what's behind exponential smoothing. How does it work? Because I mean, if you're in the forecasting business, I mean, most software packages like SAP and IBM stuff, they'll have this built in. Okay, so you should understand how it works. So let's see, it would be auto sales. Yeah, here it is. All right. Yeah, okay. So if you think about a time series like monthly US auto sales, we're all familiar with that. There are three things going on in a time series. Think of it as monthly, but it could be quarterly, it could be daily. There's a base level of auto sales per month. Okay? Maybe 500,000, 600,000. Now the problem is we never know that because of the seasonality, right? Then there's a trend. Like what does a trend of 2% a month mean? It means the base is going up 2% a month in auto sales. It would never be that high. It might be 2% a year. Okay, but the trend keeps changing. If you don't believe that, look at, if you saw The Big Short, which I haven't seen yet, but I heard it's a great movie. Okay, but basically, the trend in housing prices in the LA and Las Vegas area was extremely positive till what, 2006 or 2007? Trend changes. You can't see the previous models, we assume those parameters were constant. But you want a model that adapts to what's going on in the real world. That's why smoothing is so good. We'll explain in a second. Then there's a seasonal index. So what does a seasonal index of 1.3 mean? A seasonal index of 1.3, like Amazon's fourth quarter has a seasonal index around 1.3. It means the fourth quarter you sell 30% more than an average quarter. Now Microsoft has a different seasonality. What's the key to seasonality at Microsoft? The end of the fiscal year and the end of each quarter, because the sales force won't get their commissions basically at the end of unless they meet their goals. So most tech companies, the seasonality is totally different. If I was doing Apple, they do have a high fourth quarter seasonality because those things are a lot of times Christmas gifts. Okay, but every company has their own seasonality. Okay, I mean, and so I'll show you how you can quickly estimate the seasonality as a precursor to the Winters method. Okay, so I got to go really fast here. So how does exponential smoothing work? Basically, how do we make up our opinion about the world? So IU beat Kentucky last week. I thought we'd get killed. So I saw that game and I had a prior review of how good IU basketball was, Indiana University. And we beat Kentucky. I have a much higher view of how good we are. Watch us get killed Friday night. Okay, but basically the way we make it a forecast or have an opinion about something, we take a weighted average of what we thought before plus what we learned from the new data. And the question is how much weight to give the new data. And in a highly volatile situation, I give more weight to the new data. If I'm watching the NBA, one game means nothing. The Warriors lost to the Spurs last Saturday. That doesn't mean anything. The Spurs went out and lost to the Hornets Monday night. Figure that. But you see that the Lakers actually sometimes win a game. Okay, sorry about that. I'm not a Kobe Bryant. If you're from LA, you deserve it. Okay, my daughter went to USC, so I mean, I'm not an anti-LA person, but the Lakers are really poorly run. Byron Scott says, don't take three-point shots. Talk to me outside about how dumb that is. Okay, every shot in NBA should be a three-pointer or a layup. That should be your goal. Okay, and you'll do pretty well if you just adhere to that. Okay, but so like how do I update the base? X is what actually happens during the month. So then I deseasonalize it. So in other words, if you saw Amazon sold 500 and it was the fourth quarter and the seasonality was 2, let's say, you knock it down to 250 because the fourth quarter was twice an average quarter. So in other words, what's your estimate from the current month? Alpha and 1 minus alpha add to 1. This is the weight. What's your estimate of the base level from the current quarter? You divide by the seasonality. That's very important. And then you take 1 minus alpha. What was your estimate of what the base would be from the last period? Last period's base times last period's trend. I know this is too fast. I'm running out of time. But I mean, it's in my marketing analytics book. I think I have lots of stuff on it. Now, how would you update the trend? From the current month, what do you think the trend is? This month's base divided by last month's base. And then you take 1 minus beta, a different smoothing constant. The whole thing is use solver to figure these out. But basically, you take 1 minus beta times what the trend was last month. How do you update the seasonality? Suppose you sold 500 in a month in December, and last December had a seasonality of 2. Basically, I think that one may be wrong, I'm sorry. Okay, so the seasonality, we've got those formulas here. Where's the seasonality? B divided by C. Yeah, it's divided by the base. That one's wrong. I wasn't thinking. Okay, so that one, that should be LT. That didn't make sense there. Sorry about that. Okay, suppose you sold 500 in a month and the base coming in was 400. Well, then you would estimate this month was 500 divided by 400, or 25% better than average. That would estimate the current seasonality. And then you just take your previous view was the seasonality 12 months ago. And so these equations are incredibly easy to program in a spreadsheet. When I used Lotus 123, God, I don't want to say 27 years ago, that was the first example I gave them in class. And basically, it's the copy command makes this really simple. The question is, how do you get it started? How do you get a base trend in seasonality to get it started? And so what I'm going to show you now, and it's probably the last thing I can show you, that would be how you can estimate your trend in seasonality given a set of sales data. And then basically this would update automatically. And I just want to say what I did with this method here outperformed the forecast tool. It did a little bit better. Okay. Although the forecast tool is based on this. But how would I initialize? See, the trick is how to get this started. So what I did is I used 2003 and 2004 to get it started, and then I rolled those equations forward. This is an example on airline miles. Okay, this is a of how I would estimate trend and seasonality. Okay, I guess I didn't put the auto example in here. Okay, but this is airline miles is very seasonal. Okay, so if I had 2 years of airline miles, how would I estimate trend, which is percentage change per month, and then basically seasonality? Okay, so basically the key equation is in this forecast column. Now, okay, I have to scroll up, sorry. Okay, so what are the unknowns? There's a base level. This is like the model I was doing with the Snickers. And then you have basically you have the trend raised to the power, which is the period number you're in. That's hard to see there. Let's just look at the formula. As soon as I finish this, I'm just going to have to stop. Okay, so this is formula, text. Okay, so you raise the trend to the month number. So if the trend was 2% a month, 2 months from now, you take the base, which is sort of an estimate of where you are the first month, times the 1.02 squared. 3 months from now, 1.03 cubed. Then I look up the seasonality based on the month of the year, okay? And that basically is if you want to estimate your trend in seasonality from any set of sales, that's your basic model. You have a base level, you take the trend raised to a power, and then you take basically a lookup on the seasonality, and then that's the forecast. And then you do the squared errors here, and you minimize the sum of the squared errors, use that GRG multi-start, okay? And what you would find for the airline miles is the trend was 1%. The solver window would look like this. Okay, I would minimize the squared errors. I would change the base. I would change the trend. Okay, the average monthly seasonality and multiplicative model should be 1. That's what this is. Then I said the seasonality should all be less than or equal to 3 to use that multi-start. You can't go up more than 100% a month. Then I said the base was less than 1,000. And then I used that multi-start. Okay, and I think this is the right answer. But I'll run it just to see if it does any better. I think it's not showing the whole screen here, but it does. Okay. Oh, I used evolution. Oh, I did use evolutionary here, I believe. Okay. So in other words, how did evolutionary? No, I used the nonlinear. I'm sorry. Okay, and I used the multi-start. But again, we're running out of time here. But let's look at the seasonalities here. And this would feed into the when you did this for the autos for the previous spreadsheet. But like when are the airports busy? Well, always is the answer. But basically, June and July here, but that doesn't, it looks weird that August is not that busy. Okay, but May, June, and July, oh, I'm sorry. This is the auto data. Okay, it says airline miles. Okay, so I mean, I apologize for this. Okay, I forgot to change the heading there. Okay, so the trend was 1% a month for these 2 years where I started. These were really good years for the auto business. And basically, what's the busiest time of the year for auto sales? March, April, May, and June. Basically, the spring. You get your tax refunds. You want a new car for the summer. There's not going to be snow to ruin your white car if you're in the north. Okay. But basically, this would say after adjusting for trend that May was 16% above average. What's the worst month? August was the worst month for new car sales. Okay, sorry, September. Now, why is that? I'm not sure, but new car sales appeared to be 80% of a normal month there. So this stuff would get fed into the previous spreadsheet. It would update over and over, and then basically you'd find the base trend and seasonality smoothing constants that would minimize squared errors. Let me just show that, and then I'll take a few questions, but then I got to stop. But basically, if I go back, that was the auto data, I'm sorry. Okay, I could see. But basically, my alpha was 68%, which means I would give 2/3 of the weight to the current month, 1/3 to the previous. The beta was near zero. What does that mean? I wouldn't change the trend at all over the time period I looked at. The gamma was 0.55. The seasonalities have to update. But basically, I compared what I got from this to the forecast tool, and it was more accurate. My mean absolute, how much was I off by? Here I didn't use squared errors. I used another measure called mean absolute percentage error. I was off by an average of 8% per month. Okay, not great, but I mean, you know in your business how accurate you need to be. So I have, I think, 3 or 4 minutes for questions. I'm sorry I couldn't get through that, but more than I thought. But any questions on, but the basic principle, let me go through that. Come up with an equation with parameters. You don't have to know what the values are. Put in anything. Okay, create a forecast based on those values of the parameters for your data. And then minimize the sum of the squared errors, have the solver pick the parameters, maybe with multi-star. And one thing I didn't mention, we should do validation. If we have a lot of data, use 80% of our data to fit the model and 20% to see if the error is fairly similar. Because if it can't predict out of sample, it's really not worth anything. Okay, and that's very important. That's very important. But if anybody, I know the next person could come in and talk. So, but if anybody has a question, but feel free to contact me at that winston@indiana.edu. I may have a few business cards left. But I'm always interested in hearing from people who have real jobs, who not personal but professional problems. I'm very interested in. Okay. Oh, thanks.